guys, it's Miss Fiala. I just want to go over today's math lesson with you. Today is Thursday, 4/16. When you open up your attachment, here is your FSA countdown page that you have to complete. And when you scroll down, here is your worksheet page that you have to complete for today's lesson. Today's lesson is on comparing fractions, okay? When you go over the FSA countdown page, it's actually all on comparing fractions. So after you watch this video on the lesson for today, these questions should be pretty easy for you. So if you have any other questions, private message me on Edmodo and I can help you with those individually, okay? So let's go over the lesson for today. So I'm going to turn this around so you can see my board again. Go ahead and set this up for you. Alrighty, today's lesson for equivalent fractions, for comparing fractions. Yesterday we did our lesson on equivalent fractions, okay, which can help us a little bit with the comparing fractions too. So when we compare fractions, that means we are finding if a fraction is greater than, less than, or equal. Okay, so we use those symbols to compare fractions, just like we use those symbols to compare regular whole numbers. And some of us get confused with those symbols, so I'm going to go over those first. So greater than would mean the opening points to the larger fraction. So think of the alligator mouth is open, that's going to the bigger fraction, okay? The less than symbol is where the point, the little dot, that one points to the smaller fraction. So here, that little point is pointing to the smaller fraction. The big opening goes to the bigger fraction, okay? And then for equal, you just put an equal symbol, okay? So that's greater than, less than, or equal to. Alrighty, so we're going to go ahead and compare our fractions. So for example, if you have a fraction such as 1/3 and we want to compare it to 2/5, okay? There's a couple ways that we can do this. I'm going to show you one way, and then I'm going to show you another way. The way that I'm going to show you right now, I think, in class when we did this was a little bit confusing, so if you don't want to use this way, you don't have to, because the other way is definitely a little bit easier, okay? So to find an equivalent fraction, what we can do is list the multiples, not factors. I know we do a lot with listing the factors. Yesterday for finding equivalent fractions, we found factors to divide, but here we're going to list the multiples of the denominators, okay? And then we need to find a common multiple. So when you're doing this, whenever you get a problem comparing fractions, you will always be able to find a common multiple. You're not going to be given a question where you can't find a common multiple, okay? So what we have to do is list the multiples of the denominators. So right underneath each of these fractions, I'm going to do that. So I'm going to start listing my multiples. Remember, multiples, we think of skip counting. So I'm going to start with the number 3. And 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. I'm going to stop there, and now I'm going to start with listing my multiples of 5, because sometimes you don't have to keep going for very far before you find that common multiple. So let's start listing our multiples of 5. 5 plus 5 is 10, 15. I can stop because I know I just found a common multiple of 15. They both share a multiple of 15. That is going to be my new denominator. So just like we did yesterday with equivalent fractions, I have to make an equivalent fraction with a denominator of 15. So 1/3. We have 3 as our denominator here. What times 3 is going to give me my new denominator of 15? Well, 3 times 5 will give me 15. So that equals 15. Again, whatever you do to the bottom, you do to the top. So I'm going to multiply 1 times 5, which is 5. My new equivalent fraction is 5/15. 1/3 equals 5/15. I did that by multiplying by 5 over 5, which is what we did yesterday. So now let's look over here. I need to find a denominator of 15. Well, what times 5 will give me 15? 3. That's my new denominator. Now I multiply by 3 on the bottom. I need to multiply by 3 on the top. Remember, we multiply by 1 whole. 3 over 3. So 3 times 2 is 6. Now I am comparing 5/15 compared to 6/15. When you are comparing fractions and they have the same denominator, all you have to compare are the numerators. So if I have 5/15 compared to 6/15, the denominators are the same. That makes this really easy. What's greater, 5 or 6? 6 is greater, so I'm going to put that big opening to the 6/15, okay? So 6/15 is greater, which means, well, what was 6/15 originally? 2/5. So 2/5 is greater than 1/3, okay? So what we need to do when we compare fractions is make them have the same denominators. We can't compare fractions if they don't have the same denominators. Same with adding and subtracting fractions. We can't do that unless they have the same denominator, okay? So let's do another example with doing it that way. So let's compare 4/7 compared to, let's see, 16/21, okay? Sometimes you will get larger fractions. So I wanted to give you an example. First thing we're going to do is list the multiples of each denominator. So I'm going to do that right underneath. So 7 plus 7 is 14, 14 plus 7 is 21. I'm going to stop because when I start listing my multiples of 21, I can stop already. They have a common multiple of 21. That is going to be your denominator, okay? So if I look at this fraction, 16/21, it already has a denominator of 21. So I don't have to do anything to that fraction. I'm going to keep it as 16/21. Over here, now I need to ask myself, what times 7 is going to give me my new denominator of 21? Well, 7 times 3 gives me 21. Now, whatever I do to the bottom, I do to the top. So what's 4 times 3? It is 12. So now I'm comparing 12/21 compared to 16/21. Now all I have to do is look at the numerators. What's greater, 12 or 16? 16 is greater, so the big opening is going to go towards the 16/21. So if I look back up here now, what's greater, 16/21 or 4/7? It is 16/21. Okay? And that's how I compared those fractions. You can always list the multiples and find equivalent fractions that way to compare your fractions. Okay, this other way I'm going to show you, which we've done in class and you might remember, is the butterfly method, okay? Or some of you call it cross multiplication. That's fine too. Okay, so here are my two fractions. I could use the first way I just showed you, and I could list the multiples of each denominator and find a common multiple. Or I can use that butterfly method, which means I multiply the numerator by the opposite denominator. So here I'm multiplying 5 times 6. 5 times 6 is 30. I'm going to put that 30 over here at the top. Okay, I did 5 times 6, gave me 30. Now I'm going to do 4 times 9, which is 36, and I'm going to put that right at the top over here. When we use the butterfly method, we are still finding equivalent fractions, okay? Because if I did 5 times 6, I got 30. I would also do the 9 times the 6. Remember, we multiply the same top and bottom. And 9 times 6 gives me 54. So this is really 30 over 54. And now this, if I did 4 times 9, I would have to do 6 times the 9, which gives me, same thing, 54. So now I have the same denominators. Remember, we can't compare fractions without having the same denominator. So all I need to look at now are the numerators. Which one's greater, 30 or 36? 36 is bigger than 30, which means 4/6 is bigger than 5/9. Okay? Now, a lot of times in class, though, we don't do the denominator because all we have to do is look at those numerators. And you can do that either way, okay? But I wanted you to understand that these are equivalent fractions that we are finding to compare 5/9 and 4/6. All right, let's do another one with using that butterfly method. Let's say we have 2/5 compared to 3/6. So again, we're going to use that butterfly method. So we're multiplying the numerator times the opposite denominator. 2 times 6 gives me 12. I'm going to put that 12 up over the 2. Okay, and now 3 times 5 is 15. I'm going to put that 15 right over here. So now, like I said, I just have to look at the 12 and the 15. Which one's greater, 12 or 15? 15 is greater, which means 3/6 is greater than 2/5. Okay? And that, I think, is probably the easier way to do it than listing the multiples, but you could also do it that way. And don't forget, we really are finding an equivalent fraction, because if I did 3 times 5, I'm going to do 6 times 5, which gives me 30. And if I did 2 times 6, I would have to do 5 times 6, which gives me 30. They have the same denominators. So 2/5 equals 12/30, and 3/6 equals 15/30. So now we're comparing the equivalent fractions. Okay? All right. Let's do one more like that. Let's do a bigger one. What if I did 9/12 compared to 6/8? Okay? You could list your multiples, or we can use that butterfly method. So I need to do 6 times 12. And yes, sometimes when you do your cross multiplication, you might have to multiply larger numbers. We can do that, though. Even if this was a 2-digit number times a 2-digit number, we still should be able to do that because we've already learned that, okay? So what is 6 times 12? And if you don't know 6 times 12, then you can do it on the side of your paper if you need to, okay? So 6 times 12 is 72, so I'm going to put that up here, okay? And I did that down here. Okay, my multiplication, again, if you don't know, you need to do that on the side of your paper. Now I'm going to do my cross multiplication, 9 times 8. Again, if you don't know that multiplication, skip count on the side of your paper, or use your standard algorithm to multiply that. Use your box method if it's a 2-digit times a 2-digit number. So 9 times 8, I know is 72. If you didn't know that, you can skip count by 9, 8 times, 9, 18, 27, 36, 45, and you can keep going, okay? Until you get to 9 times 8, okay? If we did, that was 1, 2, 3, 4, 5, so 9 times 6 is 54, 9 times 7, 63, keep going, 9, and then 9 times 8 is 72, okay? And that's how I got my answer. If I look, I'm comparing now 72 and 72. Those are actually equal. So those fractions are equal to each other, okay? Which we might not have thought that by looking at those two fractions. That's why we do our work. And we show our work to prove that, okay? A couple tricks that I want to go over with you when we did this in class. If your numerators are both, say, 1. Okay. If your numerators are both 1, the one with the larger denominator is actually smaller. So 1/7 is smaller than 1/5. So I'm going to put my big opening to the 1/5. Okay? So this is a trick that you can use so you don't actually have to do any of that cross multiplication. If I did, I would find 1 times 5 is 5, and 1 times 7 is 7, and 7 is greater than 5. Okay? So that is a trick that we can use. And we can also use that trick even if the numerators are the same but a different number. Say we had 2/5 compared to 2/7. Which one has the larger denominator? This is the larger denominator. That's actually smaller. And I can prove that if I did my cross multiplication. 2 times 7 gives you 14. 2 times 5 only gives you 10. Okay? So anytime the numerators are the same, the one with the larger denominator is smaller. Okay? So that's a trick that we can use. Alrighty, if you have any other questions on comparing fractions, send me a private message on Edmodo and I can help you a little bit more. Okay? Don't forget today you have to do your FSA page, then you're going to do your math worksheet for comparing the fractions, and then you have to do your one Imagine Math lesson on your FSA Review Week 4 pathway. And after watching this video and doing your practice worksheet, these lessons on Imagine Math should be pretty easy for you to pass. If you find that you're not passing these lessons, then you need to contact me because we really should be able to pass those. And if you're struggling with your worksheet, then you should be asking me questions before you get to your Imagine Math lesson, okay? Your code word for today is Edmodo. That is what we have been doing all of our e-learning on. So this is our code word for today, okay? Let me know if you have any other questions. Thank you. Bye.